Alright guys, this is part one of the review of conic sections. Alright, this is going to, this review, once you put together part one and part two, is going to cover all four conic sections: your circle, your parabola, your ellipse, and your hyperbola, all of which will be on the next test. Please put down your pencils and pens. If you're watching this video, you need help. Learn how to do the problem, but you've got to go back and do the problem yourself. Otherwise, you'll come into the test and you won't be able to do the problem. Surprise, surprise. Okay, well, we have a choice. We could set these equations equal to each other, and like we often do, and start subtracting things to cancel them out. But today I want to show you another technique, because after all, this is the elimination method, and it's just lined up so pretty, and it's all about canceling out one of the variables. Now the way it is, see how the variables are all lined up, and the y's would cancel just the way they are, and even the other y's, the positive 8 and the negative 8, they would also cancel out. So you know, because they're all lined up and everything, it's slightly quicker than setting them equal to each other. So we could just do this and combine these into one equation. So 1x squared plus 1x squared would give you 2x squared. Those are gone. Negative 4 and negative 4 is negative 8x. Let's see, negative 5 and negative 37 is negative 42. And that's all equal to 0. So this is another way of approaching the same problem. Okay, so now we only have one variable. That was important. So let's solve this. I'm noticing a common factor. So let's just divide everything by 2. Okay, so that's going to give us x squared minus 4x minus 21 equals 0. This is going to factor down for us. X squared is x times x. 21, I'm thinking 7 times 3. Now inner we have 7x, outer we have 3x. To get a negative 4, we need a negative 7 and a positive 3. So there's your negative 7, there's your positive 3. Also, a negative 7 times a positive 3 does give you a negative 21. So it checks out. Of course, to get the actual values, we have to set these equal to 0, like so. Okay, I'm adding 7 to both sides, so that gives us x equals 7. Subtracting 3 from both sides gives us x equals negative 3. Okay, these are not the final answers because we still need the y values to go with this. So I'm going to make a t-chart. So x and y. So we have our x values so far. We have our negative 3 and we have our 7. Okay, we just need the y values to go with them. So let's start with the negative 3. To get the y value that goes with it, you need to take that negative 3 and plug it into one of the equations. I'm going to plug it into the top equation because why not? So I'm putting negative 3 for all the x's. So that means I'll have negative 3 squared, because that's an x. Alright, plus y squared, that's just going to stay what it is. Minus 4 times negative 3, because that's another x. Plus 8y. Okay, minus 5 equals 0. Okay, so this is all y's, so I should be able to solve for this. This is going to give me 9 plus y squared plus 12. Okay, plus 8y minus 5 is equal to 0. Okay, now looking at those constants, looking at those constants, hold on. respect my authority. Alright, looking at those constants, I said, it's going to be like 9 plus 12 minus 5, right? So let's see, 9 plus 12 minus 5. So that's going to be 16. Okay, so that means I've got y squared plus 8y plus 16 equals 0. So this will factor. So y squared is y times y. 16 can be a bunch of things. For example, it could be 4 times 4, or it could be 2 times 8, or 1 times 16. Well, I guess that's it. It's not really a bunch of things. But anyway, looking at the middle of 8, it's all about 4 and 4. Positive and positive gets it done. Inner 4y, outer 4y, there you go. Now, of course, if we set these equal to 0, I'm going to have y plus 4 equals 0. And this would be the same thing twice, so it's kind of silly to do it again. But subtracting 4 from both sides, I get y equals negative 4. Okay, so back to my t-chart. When I plugged in negative 3, I got negative 4 for my y value. Okay, well, let's plug in 7. Let's substitute 7 and see what we get. So I'm just going to use the same equation again. Okay, I think I'll change colors just to see it better. So now I'm doing the same thing with what did I say, negative 7? Positive 7. Okay, so I'm going to have 7 squared plus y squared minus 4 times 7 plus 8y minus 5 equals 0. So I just have to solve this out. So this is going to be 49 plus y squared minus 28 plus 8y minus 5 equals 0. Okay, so hold on. So 49 minus 28 minus 5. 49 minus 28 minus 5. So that's 16. So we're going to have plus 16 equals 0. So 16, looking at the 8, I'm liking 4 times 4. So this is going to give me y plus 4 and y plus 4. And wouldn't you know it, if we do y plus 4 equals 0, that's going to give us y equals negative 4. Well, that's the same thing we got last time. These won't always be the same, but this time it was. So there you go. So these are the solutions. So the solutions are negative 3, negative 4, and 7, negative 4. Okay, so that's how you can solve a system. That's one way to do it. Alright, looking at these equations, the first thing we have to do is decide which kind of conic section this is. Alright, we have to name it. And if only one of the variables is squared, then you know it is a parabola. So let's write that down. Alright, so we know it's a parabola. Okay, we even know that the y is squared, so that tells us that we're shooting for this kind of a form, like y minus k squared is equal to 4p times x minus h not squared. This is what standard form is going to look like. We just need to find the k and the p and the h. Okay, so since the y is squared, we're going to get all the y's on the left. We'll put the x's and the constant, the 7, on the right. Okay, so we're going to have this. Y squared plus 6y, leave a space, and then, alright, the 8 and the negative 7 have got to go. So I'm going to have negative 8x plus 7 because I subtracted 8x from both sides and I added 7 to both sides. So kabam. Anyway, completing the square. So half of the middle squared. Half of this is 3. 3 squared is 9. Please make sure you add it to the other side as well. So that is going to give us, because we can factor this now, so this will be y plus 3 squared equals, and so far I've got negative 8x plus 16, combining these. Alright, we need the parentheses over here as well for standard form. And the way we can do that is by factoring out the negative 8. Let's bring that outside of parentheses. Now this is going to leave 8 minus 2 behind. If you had any question about that, understand that when you factor out a number, you are dividing. So what's really happening is I'm dividing by negative 8. And 16 divided by negative 8 is negative 2. Okay, well, you know what? This is standard form, so I'm just going to recopy it down here where it goes. So standard form, we have y plus 3 squared is equal to negative 8 times x minus 2 not squared. Alright, what do we need next? Okay, we need the vertex. The vertex is going to be the opposite of these. Don't forget the x comes first, so the vertex is going to be positive 2 comma negative 3 in that order. So 2 comma negative 3. Alright, let's go ahead and graph that. So 2 comma negative 3, the vertex will be right here. Before we get too carried away, is this going to be up, down, left, or right? Well, when the y is squared, it's either going to be left or right. Because it's negative, that means it's going to be opening to the left. Okay, so we know it's going to be doing like this type of thing. Alright, anyway, we're supposed to find the focus now. But in order to find the focus, we need the p-value. So remember this, 4p is equal to negative 8. So if I were to divide both sides by 4, I would get that p is equal to negative 2. Okay, so I knew that the parabola was facing to the left. But now I know that the focus will be to the left by 2. So starting from the vertex, if I go left 2, that puts my focus right here. So that is the point 0 comma negative 3, by the way. Alright, the directrix should be the same amount in the opposite direction. So the directrix should be right here. Alright, 2 to the right. Okay. Alright, so there is my directrix. A vertical line is always x equals a number, so that's going to be x equals 4, looking at where it landed. Now, the focal width. The focal width is just going to come from this number right here in front of the parentheses, Not negative though. The focal width is always positive. So let's just say 8. Now let's use the focal width to finish this graph. That means that at the focus, the parabola has a width of 8. So that means if I go 4 up from the focus and 4 down, that's going to give me my width of 8. So now I could go ahead and graph my parabola, which is going to be doing this type of thing. Okay, so there it is. Okay, I think that's all there was to that one. Okay, so we're finished with number 2. Let's run over and take a look at number 3. Alright, first we have to decide what kind of shape it is. Both of them are squared, so I know it's not a parabola. Neither one of these terms are negative, so it's not a hyperbola. Okay, so that leaves a circle and ellipse. If it were a circle, both of these coefficients would be the same, like 16 and 16. So it must be an ellipse. So let's write that down. This is an ellipse. Okay, now, since both variables are squared, we're going to have to complete the square twice. So let's get our x's together by doing 16x squared plus excuse me, 64x, and then over here I'm going to have plus 25y squared minus 250y. Okay, let's move that 289 out of the way. So that'll be negative 289 on the other side. Okay, before we can complete the square, we need to factor out this 16 outside of parentheses. So I'm going to have 16 outside the parentheses. Inside, that's going to leave x squared. Now remember, when you factor something out, what you are doing is you're dividing by that thing. And so those would cancel. But 64 divided by 16 is 4. So this will be plus 4x. Okay, same thing here. Let's factor out the 25. So that's going to leave y squared. And once again, I'm dividing by 25 really. So that's going to leave 10. Alright, so we'll have minus 10y is equal to negative 289. Now we can complete the square. Half of 4 is 2. 2 squared is 4. Now I need to add something over here, but it won't be 4. This is 16 times 4, which is 64. So that's what I have to add. Half of this is 5. 5 squared is 25. Alright, but this is not a 25 really. This is a 25 times 25. Is that 625? Yeah. Okay, so I need to add 625 to both sides. Alright, so cleaning this up a bit, so I will have 16. This will factor as x plus 2 twice. Then I've got 25, and this will factor as y minus 5 twice. So it's just a matter of what all this is over here. Okay, so this is going to give me, so I've got negative 289 plus 64 plus 625. That's 400. Check it out. So this is 400. I know for an ellipse I need a 1 over here, so I'm going to need to divide everything by 400. Okay, 16 goes into 400. Alright, so 400 divided by 16, that's 25. So this will be x plus 2 squared over 25. Alright, but that means 25 goes into 400 16 times. So this will be y minus 5 squared over 16 is equal to 1. Now that is the standard form, so I'm just going to copy that down real quick. So once again we had x plus 2 squared over 25 plus y minus 5 squared over 16 equals 1. Okay, now the center is negative 2, positive 5, the opposite of these. Okay, so negative 2, positive 5, that's my center. So I already graphed that, so negative 2, 5 is right there. Now the vertices are going to come from the bigger value for ellipses. Alright, they're both positive, so it's all about the bigger value. So this gives me my A, which is 5, and this is where the vertices come from. Because this is with the x term, when I do my 5, I'm going to do it left, right, because that's the x direction. So 2, and there's 5, and then there's 2, and then 5. These are my vertices. So what do I have here really? So this is negative 7, comma 5. And 3, comma 5. Okay, let's talk co-vertices. The co-vertices are going to come from this b value, which is the smaller one for ellipses. So that's a value of 4. Because that 4 is with the came from the y term, it will be an up 4, down 4 situation. So up 4, down 4. So these blue points are my co-vertices. So that's negative 2, comma 1, and negative 2, comma 9. Those are my co-vertices. Okay, now the foci, or foci, we need the c value for that. So we know that c squared is equal to a squared minus b squared. For ellipses it's minus. For hyperbolas it's plus, so be aware. Okay, so that means, let me squeeze it in over here. That means c squared is equal to 25 minus 16. That means c squared is equal to 9, which means that c is equal to 3. Okay, so that means I'm going to go 3 to the left and right of this center point. Alright, the foci will always go in the same direction as your vertices. So 3 to the left puts me here, and 3 to the right puts me right here. So my foci are negative 5, comma 5. And 1, comma 5. Alright, those are my foci. Now, the length of the major axis. Alright, yeah, let's go ahead and draw the ellipse. So, the ellipse is going to be something like this. Alright, it's not great, but what are you going to do? Okay, so the major axis is the length the long way. Alright, it's always going to be double this A because it's 5 and 5, so all the way across, that's 10. So the length of the major axis is 10. Now the minor axis is going to be the short way across. So that's up 4 and down 4 for a total of 8. Alright, and I guess that is it for Mr. Ellipse. Okay, number 4. Now, you don't have a graph, so you will need to do some sort of a bootleg graph of your own. I didn't leave you a lot of space because I didn't want to make a whole packet. So you might need to do it on scratch paper or if you need to. Okay, but I'm going to do it nicely on a graph so that you can read my work and understand what I'm doing. So they're telling us it's a hyperbola right away. Okay, so they gave us the vertices. So the vertices are negative 5, 5. So here's negative 5, 5. So there's a vertex. And negative 5, 1. Okay, so negative 5, 1. So those are my two vertices. Okay, right away that tells me that this is a vertical hyperbola. It's up and down, which means that the y term is going to go first. So I know this is going to be like our y minus k squared situation. Okay. And hyperbolas are always minus. And then we'll have our x minus h squared. Alright, so this is the model that we're working towards. Again, if it's vertical, then I know that my y term is going to be first, the positive one. Anyway, we also can look at this and figure out what the center is very quickly. The center should be halfway between the vertices. So here's my center, and it is at negative 5, comma 3. Okay, so because my center, maybe I'll write this down. Because my center is at negative 5, comma 3, well, that's my h and my k. So don't get mixed up. This is the x value, so it goes with the x term. And watch how it's kind of the opposite of what you see here. Because this is negative 5, then I'm going to wind up putting x plus 5 in here. Because this is positive 3, I'm going to wind up with y minus 3. So it's like the way we do the opposites. Okay, so that's the top half of this equation. Okay, we still need our a squared and our b squared. But you know what? We can get one of those values, again, straight from the graph. Because the a value always pertains to the vertex here. So this is the a value. Besides, I mean, this is up and down, so you know this is the value that goes with the y's. But check it out. Looking at this distance to the center, I know that a is 2. So that means a squared is going to be 4. Okay, so all I really need is b and b squared. To get that, I think we're going to need the other information. we're given the co-vertices, -9, 3. Okay, so this is -9, 3. And I could probably guess -1, 3. So those are my co-vertices. By the way, notice that even though this is smaller, still these are my vertices. Okay, for ellipses, the bigger value was always going to be the vertex. But for hyperbolas, that doesn't matter. It doesn't matter which one is bigger. For hyperbolas, it's the one that's first and positive. That's the vertex. So in this case, the y direction. Anyway, from the co-vertices, I can see that the b value, which is right here, is 4. So this tells me that b is equal to 4. Square that and you get 16. Okay, and that's it. This is what we were supposed to find, the standard equation, and now you've got it. Okay, so the graph thing, that was really like optional or something. Okay, number 5. Okay, a circle with diameter with these endpoints. We need to find an equation for this circle. Okay, this problem used to give you guys fits. So I'm hoping that you figured it out finally. But let's go through it. Circle with diameter. So you should be drawing pictures, you guys. So let's get our circle going. Alright. Okay, so let's do our diameter like this, maybe. Okay, so there should be a center in here somewhere. Okay, let's say that's my center. Okay, so the endpoints of the diameter. So we could just call this. Alright, so this will be our -8, 29. And we have our 2, 5. Okay, so we need to find the equation of the circle. Now, if you want to find the equation of a circle, you need two things. You need the center, and you need the radius. Alright, if you have those two things, you can write the equation. So let's start by finding the center. Okay, the center is just going to be the midpoint of these 2 points. And the way you find the midpoint is you find the average of the x's and the average of the y's. Average, that means you add them up and divide by 2. So looking at the x's, -8 plus 2 divided by 2. And looking at the y's, 29 plus 5 divided by 2. This is going to give me my center. Okay, so this is going to be -6 divided by 2, and this is going to be 34 divided by 2. Okay, and finally this is going to give me -3, 17. Okay, so this is the center. Alright, -3, 17. So that gives me a big part of the equation. Okay, so so far I know that the equation is going to be x plus 3 squared plus, and then y minus 17 squared. Okay, opposite of this and the opposite of that. Alright, that gives you all this. Now all we need is the radius now. Okay, because this should be the radius squared. So let's find the radius now. Now if I were you, I wouldn't find the radius using this point that we just found, because if we made a mistake, then that's just going to make us get both things wrong. So instead, I'm going to use the diameter, because that was given, so I know that's right. So let's use the distance formula. So what we're doing is we're going to try to find the radius. But first we're going to find the diameter. Okay, so D stands for diameter right now. So the diameter is going to be square root of, alright, I'm just doing the distance formula, and it's going to be x minus x. So I'm talking about -8 minus 2 squared. And then I'm doing y minus y. So that's 29 minus 5 squared. Okay, I'm going to let my calculator help me out. Okay, so I'm doing the square root of, let's see, -8 minus 2 squared, and then plus 29 minus 5 squared. So that gives me 26. Alright, so my diameter is 26. Okay, now our goal was to find the radius though. So obviously finding the radius will be simple now, because the radius is just going to be half the diameter. Alright, and so that gives us a radius of 13. Okay, and that means that the radius squared is 169. Alright, 13 squared. And that's what we really needed, because right here in the formula is the radius squared, so don't just throw a 13 up there, it's got to be 169. Okay, and that is it. This is the equation that we were looking for. Okay, so that was number 5. Alright, number 6. Alright, number 6. We're told it's a parabola with a focus at -3, 2. Okay, so -3, 2 is right there. So here's a focus. And we have a directrix at x equals 1. Now, that's a vertical line. Alright, so I'm going to put a vertical line at 1. Okay, so here's what we have so far. Now, we should know exactly where the vertex is right now, because the vertex should be halfway between the focus and the directrix. So we know the vertex is right there. That means this parabola must be facing in this direction, wrapping around that focus. Okay, the point is, not only do I know the vertex, which, let me write that down by the way, so my vertex was the point -1, 2. But because the graph is sideways, I know this is going to be a y² type of a graph. So I know we're dealing with y minus k squared is equal to 4p times x minus h. I know we're dealing with the y² version because it's sideways. Also, because it's going to the left, this 4p number better turn out to be negative. Okay, but we know what the vertex is, so that's your h and your k. Make sure you put the x value in the x position. So this negative 1 is going to become a plus 1, kind of do the opposite. This positive 2 is going to become minus 2, opposite. Okay, all we need is the p-value. Well, guys, the p-value is just this value right here. Alright, between the focus and the vertex. So that tells me that p is, and I'll go ahead and say negative 2 because it's to the left. So if I plug in a negative 2 right here, 4 times negative 2 is negative 8. So that would give me a final answer of y minus 2 squared is equal to negative 8 times x plus 1. Okay, so that would be your answer for number 6. Okay, so for number 7, we're given that it's an ellipse and it's got these co-vertices of negative 2, negative 6, alright, and 10, negative 6. Alright, so those are my co-vertices. So this must be the short way. And then we're given foci at 4, 3. Alright, let me just get this going. Foci are at 4, 3 and 4, negative 15. Wow, that's going to go right off the graph here. So negative 15. So this is negative 10, so like 11, 12, 13, 14, 15, whatever, somewhere around in here. Okay, this is negative 15, by the way. Okay, what about it? What of it? So, what can we put so far? So far, that means we know what the center is. The center should be halfway between the co-vertices. So this is, let's see, that's 10 and 2. They're 12 apart. So if I go over 6, that should be halfway. So 2, 4, 6. So plus it should, I knew it would line up with the foci. So there's my center. So by the way, my center is the point, let's see, 4 comma negative 6. Okay. Now, we know that these blue dots were called the co-vertices. So that means this is the short way across. So we'll come back to that in a second. Now, since we know the center, we can go ahead and write the top part of this equation. It's going to be the opposite of these. So this will be x minus 4 squared. Alright, ellipses are always plus, unlike hyperbolas, which are always minus. Anyway, we'll have y plus 6 squared, opposite of that, equals 1. Okay, now, for ellipses, okay, so look, we've got the co-vertices are like our b value. Okay, it's horizontal. So that's going to be the x. But anyway, what I'm trying to tell you is I'm looking at the b value right here. So b is, what did I say this was? 1, 2, 3, 4, 5. b is 6. Okay, it's horizontal. So the 36 is going to go with the x's because it's horizontal. Okay. We have the b value. Now, we have the c value, which does not go in the equation, but we're going to need it to find a, because we know that this right here is supposed to be a squared. So we need to find a. But to find a, we're going to need c. So here's the c value right here. Okay, so that's 6, 7, 8, 9. Okay, so this c value is 9, so c equals 9. So I have b and c, and I need to find a. So guess what I'm going to do? I'm going to use this formula. C squared is equal to A squared minus B squared. This is the formula for ellipses. For hyperbolas, it would be plus. Anyway, so I know that C is 9. So that means 9 squared is equal to A squared minus 6 squared. Okay? So that means 81 is equal to A squared minus 36. Adding 36 to both sides, okay, that's going to tell me that A squared is equal to 117. Now, you're going to be tempted to take the square root of this or something, but that's not necessary. We don't even have to graph this. We just need the equation. And in the equation, we need A squared. Well, A squared is 117, so we don't need to take the square root or anything. We'll just put 117. Okay, and that is it. That's the standard form equation. Alright, let's go on to number 8. Alright, number 8 is a hyperbola. We have let's see, a focus at negative 15 comma 1. So negative 15, 1 would be here. And we have a focus at 5, 1. So 5, 1 would be right here. Okay, what else we got? Oh, we got co-vertices. So we have foci and co-vertices. So let's see, co-vertices, I do those in blue. So negative 5 comma 9 for a co-vertex. So negative 5, 9. That's a co-vertex. And negative 5, negative 7. Would be right here. Okay, so we should be able to judge a bunch of things from this information. First of all, we should know what the center is. Okay, the center is going to be along this line. It's really going to be where if I connected the blue points and the green points, it's where they would meet. Alright, so the center is going to be right here, halfway between everything. So my center is negative 5 comma 1. So let me just jot that down. Center. Okay, the center is negative 5 comma 1. Now this is a hyperbola. Now because the foci are going left and right, I know that this is a sideways hyperbola. That tells me that the x term should be first. So this is going to be of the form x minus h squared, alright, over a squared, minus y minus k squared over b squared equals 1. So again, I know that the foci and the vertices both go the same way. So if the foci are sideways, that means the whole hyperbola is sideways, which means the x's come first. Anyway, I also, since I have the center here, I can go ahead and put those values in. Remember to do the opposite of what you have here. So this minus 5 will become plus 5. And this positive 1 will become minus 1. Now, the b value, okay? I can do the b value right now because the b value is right here. Okay, the distance from the center to the co-vertex. That's your b value. So that tells me that b is equal to, what do I have here? This goes up to 9, but it starts at 1, so that's 8. The b value is 8. Okay? And, you know, you see that this b value is vertical, so you know that the 8 is going to go with the y's, because it's vertical. So I need to do 8 squared, so this is going to be 64 over here. Okay, now we need to find a, but they did not give us enough information to just have a right now. What they did give us was c. Alright, so the distance to the foci, those distances are c. So let's see, this is -5, and this is +5. So that's 10. Yeah, from -5 to +5. So c is 10. Okay, that doesn't go anywhere, but that will help us find a. So remember, for hyperbolas, c squared is equal to a squared plus b squared. Okay, for ellipses it's minus, but for hyperbolas it's plus, so keep it straight. Now we're given c, so that's c squared is 100. A we don't know, so I'm just going to leave it a squared. But b squared is 64, so a squared plus 64. Subtracting 64 from both sides gives me that a squared is equal to 36. Now again, you're going to be tempted to take the square root of both sides, but there's no need, because the formula calls for a squared to be right here, and we already know that a squared is 36, so don't take the square root, just keep your 36. Alright, and that is it. That would be the standard form for this hyperbola. So that was number 8. Let's see what else they got here. Okay, we're supposed to find the equation of the asymptotes. Okay, of the hyperbola defined by this equation. Okay, so again, a sketch is in order. Look, for hyperbolas, the a value is always first. Okay, so I know that a is 2 from this. And that's the y direction. So, well, first of all, the center. Okay, let me not get carried away. So, the center is at -2, 6. Should jot that down. Center is at oh, I messed up too. It's not -2, 6. Whoo! Don't do what I did. X value is here. The y value is here. So the x has to come first. So the center is 6, -2. Okay, 6, -2. So there's my center. Now, like I was saying, my a value is 2 in the y direction, because they go together. So that means I'm going to go up 2 and down 2. And these are my vertices, if anybody cares. Now my co-vertices will come from my b value, which is 3. Now this is with the x's, so when I do my 3, I'm going to do it to the left and right, okay, of the center. So the point of this is we're supposed to be finding the equation of the asymptotes this time. That's our goal. To do that, this rectangle, it's all about this rectangle. Alright, so you could just draw yourself a rectangle connecting the vertices and the co-vertices. Now the asymptotes are going to go through the diagonals of the rectangle. So it's going to be doing this type of thing. Alright, diagonal. I like to just stretch it out. Okay, and we'll also do it the other way. Now, when we do the equation of these asymptotes, I've been recommending that we use point slope form, which works like this: y minus y1 is equal to the slope times x minus x1. Let's start with the slope. Now, if you look from the center to the corner of your rectangle, alright, what's the rise and what's the run? Well, rise over run, that's 2 over 3. So that's your slope, guys. So it'll be 2 over 3. What else? I recommend using the center as your x1 and y1. So we know that this is the center, so this will be our x1 and our y1. So I'm going to put the 6 here, so this will make x minus 6, that's my x1. And I'm going to put the negative 2 here, which it'll be like the opposite, so this will be a positive 2. So I will have y plus 2. Okay, so this is the equation of the upward sloping asymptote. The other one would be the same, except for the slope would be negative. So what you can do is simply put a plus or minus on here, and now it is the asymptote for, it's both in one expression. Okay, so that is how you find the equation of the asymptotes when all you have is an equation. Number 10. If the graph represented by this equation is translated 6 units to the right and 3 units down, okay, write the resulting conic. So we're doing 6 right and 3 down. Now, the center. The original center is the point -6, 8. Alright, it's the opposite of that and that. So let's look at this on a graph. So -6, 8 would be right here. Okay, now if I were to move this 6 right and 3 down, where would I be? Okay, well, if I went 6 to the right, I'd be here. And then if I went 3 down, I would be here. Okay, so this is the new center, alright, after this transformation. So the center is going to become 0, 5. Okay, we're talking about a circle, and we're just doing a translation. We're just sliding it. So the size of the circle isn't going to change. So this circle had a radius of 16, so the radius is still going to be 16. But using our new center, it's going to be like x minus 0 squared plus y minus 5 squared. Still going to equal 16 like before. A mathematician wouldn't put minus 0 here, so you could put x squared plus y minus 5 squared equals 16. If you left the 0 in, I'm not going to take off any points though. Can you tell from my voice it is 1:41 a.m. But I'm desperately trying to get this finished so you guys can use it for your review in class tomorrow, but man, I'm tired. And half of y'all won't even bother listening to it. You know how sad that makes me? Alright, but William will listen to it, so thanks, Will. Alright, find the equation of the line tangent to the circle at the given point. Alright, yeah, good old tangent problem. This used to give you guys all kinds of fits, but hopefully you have mastered this by now. So I recommend drawing a picture. Surprise, surprise. I'm always telling you guys to draw a picture. So we have a circle. There should be a tangent line happening. Okay, so here's my tangent line. Okay, feel like making it red. So we're supposed to be finding the equation of this line. There are 4 steps to this process. Okay, step 1, we're going to find the slope of the radius. Okay, step 2, we're going to turn that into the tangent, you know, the red line here, the tangent slope. Step 3, we're going to find b, y equals mx plus b. We're going to find b. Okay, and step 4, we're going to write the equation. Okay, now look, so here's why we're doing all this. In order to write the equation of a line, you know it's going to be y equals mx plus b. Okay, so that means we need to find m and b. So the equation is going to be like y equals something x plus something, and this is going to be our m and our b right there. Okay, so first we have to find the slope, and then we have to find the y-intercept. So that's why the first 2 steps we're finding the slope, and the third step we're finding the y-intercept, and then we plug it in. So that's like the big picture. So slope of the radius. So we have a center point in here somewhere and a radius. Okay, the radius and the tangent are always perpendicular. You should know what the center is based on these numbers here. So the center is going to be -3, 6. So there's my center. The point of tangency is the point 1, 5. So we have that. Now, as far as finding the slope of the radius, we use the slope formula. So it's going to be y minus y over x minus x. So that'll be like 6 minus 5 over -3 minus 1. Okay, please, y minus y over x minus x, put the y's in the top. On the last test, this was probably the most commonly missed problem. And the reason why you missed it was just you're adding and subtracting wrong, which is silly because you all had a TI-30 XS multiview at your disposal. So stop trusting in your ability to add and subtract. I mean, feel free to give it a try by hand, but go back and check your answer using the calculator. Don't get it wrong for when you don't have to. 6 minus 5 over -3 minus 1. That is -1/4. Okay, so that's the slope of the radius. That means the slope of the tangent is going to be opposite and reciprocal. So if this is negative, this will be positive. Alright, 4 over 1 is going to become, 1 over 4 is going to become 4 over 1, which is just 4. So this is the slope of the tangent. Now we're going to find b. So thinking of y equals mx plus b, maybe I'll write that down. We need a y, an m, and an x. Okay, obviously the m is going to be 4. Maybe I'll just go ahead and write that down. So now we just need an x and a y. Well, look over here. See these points? Which one of these am I going to use for my x and my y? Well, remember, we are trying to find the equation of the tangent line, the red line. Which one of these points is on the tangent line? Yeah, the 1, 5. Please don't try to use the center point and plug that in. Had a bunch of people do that. Okay, you have to use a point that's on the line, which is 1, 5. So obviously it's x, y. So 5 goes here, and 1 goes here. So this is 5 is equal to 4 plus b. Subtracting 4 from both sides gives me b equals 1. Okay, so check it out. We have m and we have b. Okay, so the slope, we found the slope to be positive 4 and the y-intercept to be 1. So that's why the final answer is y equals 4x plus 1. Alright, we've done that many times. So I'm hoping you guys have finally mastered the whole tangent thing. Okay, is this video finally over? It's taken forever. Alright, I think that was finally the last problem. Okay, and that was all just part 1 of the review. Part 2 will be assigned for homework. Part 2 is only like 5 questions, so it's not nearly this long. Okay, and in case you're wondering, the actual test won't be this long. There will be fewer problems, but you're responsible for all of this information for sure.